Can I start now? Are you done writing?
Yes, yes.
Okay. So if the students are faced with a question like this, it is expected of us to always, first of all, the first thing to let them know is let them be able to identify the oxidation half equation and the reduction half equation. Hence, we started with those definitions,
Okay.
Redox reaction before. So we'll do something now. We can link this one down to this point and take this one this way. Do you agree with me?
Okay.
Okay. So the one above is what? Is it oxidation or reduction? Hey, madam.
Oxidation.
Okay. Oxidation. Why do you think it's oxidation, please?
No.
So the first thing to do, like I said, is let them identify reduction half equation and oxidation half equation. If you check it, this is MnO4. This is just Mn. The only difference now is oxygen is no longer here. Oxygen has
Removal of oxygen.
so oxygen has been removed. That is reduction.
Okay.
Then if you look at the one down, based on oxidation number, this is -1 and this is 0. So the oxidation number again changes from -1 to 0. Is that an increase or a decrease? Yeah?
Increase.
Increase. So obviously this becomes
increase.
So this is oxidation.
Oxidation.
So the first thing is identify reduction and oxidation half equation. I'm not going to be putting it step by step, but just for the students, as the first example you can give them, you can put it in steps. So that's step 1. Step 1 is identify oxidation and reduction half equation. So which we have done. So I will now do this now. Reduction half equation. My reduction half equation is this one. That is MnO4 minus to give me Mn2 plus. Do you agree with me, madam?
Yes, sir.
Okay, so this is the reduction half equation.
I'm with you, sir.
Then for oxidation half equation, oxidation half equation. It's not necessary you put it step by step like this. So when they are familiar with it, they can solve one completely before going to the other one. But for the first thing, they can be doing it in bits like this. So oxidation half equation is I minus, will give me I2. Is that taken?
Yes, sir.
Okay. So I'm going to clean this first one now. Anybody, for those who just joined now, can I clean this first part? Those who just joined in now. If you have any question, those who are just coming in, let me know so that we'll all be in the same page before I continue. Okay, since we are all together. So having identified the reduction and oxidation half equation, now the next step is to balance each of the half equations. So I can decide to do this one. I can call this one equation 1. I'll call this one equation 2. Are you with me? So now let's go to reduction half equation. Reduction half equation. I'm going to clean everything here off completely. So please, someone, if you are with me, what was the reduction half equation? Can you just read it out for me? Reduction half equation. What was the reduction half equation?
MnO4 minus.
Okay, Mn44 minus.
Oh, yeah. Equal to
Not
Mn2 plus.
And give you Mn2 plus, not equal to, but give you Mn2 plus. Or better still, let me put it like this. Mn2 plus. Any question? Now, the next thing to do is to balance this equation, this particular reduction half equation. And how do we balance it? If you check here, this is Mn, this is Mn. What is missing completely?
Is that?
What is missing in this equation? What is missing?
O4.
Good. 4 atoms of oxygen. Now, this is how to do it. We'll balance the side with oxygen. We add hydrogen to the side that has oxygen. Add hydrogen to the side that has oxygen and add water to the side without oxygen. That is how we balance it.
Okay.
So we add here hydrogen and we add here water, H2O. Are you with me, please?
Yes.
Okay. Now, if I've added, how many oxygen do we have here? On my left-hand side.
What?
Oxygen.
4.
So I'll put 4 in front of my water. Because there's 4 oxygen here. If here was 3, I'll put 3 here. If here is 2, I'll put 2 here. Can I move on?
Yes, sir.
Good. Then 4 times 2 is 8. 8 hydrogen. I'll put 8 in front of this. This will be plus 8H. This hydrogen is always having a plus, hydrogen ion. So that's our balance this first. Is that okay? Then let me put here 4H2O. Any question, please? Any question? Any question?
Yes, I want to ask.
Okay.
Is it all redox titration that involves hydrogen and water in the balancing?
Good. If it is having oxygen, you add hydrogen. If there was no oxygen here, I will not add hydrogen, neither will I add water. It is only when I have oxygen, then I'll add hydrogen and water. Have I answered your question? Have I answered your question, please? Okay, now the next thing to do is we balance the charges. The charge here is -1. This is -1 plus 8 because of this hydrogen here, 8. -1 plus 8 will give me +7. That is the charge on my left-hand side. Then I'll calculate the charge on my right-hand side. Water is always 0. So this is +2. All together gives me 2. So the charge on my left-hand side is 7. The charge on my right-hand side is +2. Do we understand how I got this now? If I move on to the next thing. Any question? Okay. In the absence of any question, the next thing to do is this. We add electron to the side with the higher charge. Add electron to the side with the higher charge to balance the charges. I come again. Add electron to the side with the higher charge to balance the charges. So this side I have 7 on my left, on my right I have 2. So the left-hand side has 7, and the right-hand side has 2. That means the left-hand side has a higher charge than the right. So what I will do is I want to make sure that both of them have two charges. So if you take away 2 from 7, I'm left with 5. So I will add 5 electrons to the left-hand side. So it now becomes MnO4 minus plus 8H plus 5 electron give me Mn2 plus 4H2O. So this is your balanced reduction half equation. You can call this one equation 3 if you care to. Any question? Any question, please? Maybe at this point I have to call names now. Madam Evelyn, any question? Can you hear me, Madam Evelyn? And as well as Ufoma.
I can hear you, no question. I'm okay.
Okay, thank you very much, sir. So we'll move on to the next one now, which is the oscillation half equation. So I will clean this up. Remember, this. We'll come back and visit this, but just note this. You can leave 2 lines before you write oscillation half equation. So we'll go now to oscillation half equation.
Wait, sir, sorry. I didn't understand this electron that you write here.
Yes. Is it how we came about the electron? Yes. The electron.
Yes. How is this 6?
It's not 6, it's 5. It is 6, it's not 6, you are saying there, it's 5.
Okay, 5.
Yes.
Yes. Okay, I'm seeing it well now.
Okay.
Thank you.
Welcome. So we'll go now to oscillation half equation. Please, can you call the oscillation half equation? We'll go the other time for me. I think I have I what? I minus. Give me.
Minus.
Yes, I2.
To I2.
Good. Now let's balance it. This equation is not balanced. To balance it, we'll put 2 in front of this I. That's the first thing to do. We'll balance it by putting 2 here, because we have 2 iodine here and we got just 1 here before, so I have to add these 2 here. Now, after you've added that, you can see now there's no oxygen here. So there's no need of adding hydrogen and water to any side here. So what we are going to balance here is the charge. The charge here is -1 and the charge here is 0. Any question? Any question? Now, if you look at this, 2 times this will give me 2. So the total charge here will give me -2 because of this 2 that's in front here. Why the charge here is 0. Again, now if you look at it, the left-hand side has a charge of -2. The right-hand side has a charge of 0. Obviously, the right-hand side has a higher charge because 0 is greater than -2. So I'll be adding 2 electrons to the right-hand side to balance it. So my equation now becomes I2 will give me I plus 2 electrons. Is that taken? If you have any question, ask if I continue with the next one. In the absence of any question.
Understood. Thank you.
Okay. Now, in the absence of any question, now let's look at something now. If you check, I can call this one equation 4. This is 4, and this is 3. Now, let the student know this. Oscillation half equation always has electron on the right. Reduction half equation always has electron on the left. Electrons are always on the left-hand side for reduction. Electrons are always on the right-hand side for oscillation equation. Now, having said that, if you look at equation 3 again, the charge is 5, and equation 4, the charge is 2. The next thing to do is to balance the charges on both equation 4 and 3. And how do we do that? We will multiply equation 4. We have 5 here, so multiply this by 5. And equation 3 multiplied by 2. Any question? if I multiply equation 4 by 5, it becomes 5 times 2, that is 10i, will give me 5i2 plus 10 electron. I will call this one maybe equation 5 now. Then equation 3, since I'm multiplying that by 2, I'll give me 2mnO4 minus plus 2 times 8, 16h plus 10 electron for 5 times 2, give me 10. Give me 2mn2 plus 8h2O. I can call this one equation 6. So let's clean this up now. Now, after getting your equation 6, we are one step away from the answer. If you now check, the electron for equation 5 and electron in equation 6 are now equal. So we'll cancel out the charges and combine both equations to give us the overall equation. Cancel out the electrons. So this and this will cancel out and then combine. So we can now say cancel out the charges or the electrons and combine both equations. So we now have overall equation. The overall equation, the reactant of this and the reactant of this will be on the reactant side. The product here and the product here will be on one side. So I will now have 2mnO4 minus plus 10i plus 16 hydrogen will give me 2mn2 plus 5 plus 5i2 plus, there's no space, so that's what I'm putting this way, plus 8h2O. So this is your overall equation. And that will be the balanced equation. That's all. If you have any question, you can ask. If there's any question, you can ask. But look at one.
Sorry, sir.
Yes.
Hello, sir.
Yes, I'm hearing you.
What did you write there? Cancel at the what?
Cancel
This
out
one,
the
after
charges.
the equation, after canceling 10 electrons.
Cancel out the charges and combine both equations. Cancel out the charges. That's why you see me canceling out this. And combine both equations. That is, combine equation 5 and 6 to give you an overall equation. And when you're combining it, the product, the reactant.
So how did you combine it?
Yes, the reactant of equation 4 or your equation 6 and the reactant of equation 5 will be on the reactant side. The product here and the product here will be on the product side. So you see 2mnO4, 2m, that's this one, plus
okay,
3.
sir, why didn't you first write the... Hello, sir.
Yes, I can hear you.
Sir?
Go on.
Why didn't you first write the equation of finish as in before introducing the 10 iodine? Why do you put the 10I in between?
Yes, the 10I should come before your hydrogen ion. Or if you want to say
and the 16H. Did you get me, sir?
Yes, I get you. You are asking why is the hydrogen in between the...
Okay, because of the charges.
Yes, you put your hydrogen here and you end with water on this side. Have I answered the question?
Why?
You can put it anywhere. If you choose to put...
Okay, is it because of the negative charges?
No, there's no hard and fast way. You can bring this one, put it here. Take this one, put it here. It makes no difference. It's the same thing. So long as let your reactant all be on one side. But so that means I can have 2mnO4 plus 16H plus 10I. It's still the same thing. Have I answered the question now? Can we do one? Hello, are you with me? Are you with me?
Yes, sir. We are with you, sir. We are back.
Okay, so can we do one more example before we call it a day? Can I?
Okay, sir.
I want to clean this up completely. Let's just do one more example on this, and then we can. So I have this equation here. Balance the redox equation below. Balance the redox equation below. Fe solid plus Ag 2 plus aqueous give you Fe 2 plus aqueous plus Ag 2 Ag solid. Is that taken? Are you done writing the equation? Let's quickly what we have here. The question is, write a balanced ionic half equation for the reactions. Write a balanced ionic half equation for the reaction. Write a balanced ionic half equation for the reaction. Write a balanced ionic half equation for the reaction. And the other question is, which of the species is A, oxidized, B, reduced? Which of the species is A, oxidized, B, reduced? And C, and third, it states the change in the oxidation number of silver during the reaction. States the change in the oxidation number of silver during the reaction. Are we true? So if you are true, the first one was write a balanced ionic half equation for the reaction. Quickly, let's just look at that. A balanced ionic half equation for the reaction. So let's link this to this and take this one down. So the upside is what? Is it oxidation or reduction? Madam Evening, can you hear me? Or is it oxidation or reduction? Oxidation.
Oxidation.
Up is oxidation and down is reduction.
Okay, so we can just simply just write now.
Yes. That
Oxidation.
is from iron to iron 2 is oxidation.
Thank you.
Then from
So oxidation half equation will be Fe.
silver, as in silver ion to silver is reduction.
Okay. Give me Fe2 plus aqueous. So what do we do now to balance this oxidation half equation? This is 0, this is +2. We add electron to the side with higher charge. So where do we add the electron to? Is it the left or the right hand side? Oxidation number here is 0, oxidation number is +2. So we are adding electron.
Why am I saying?
What are you seeing? This Fe solid, Fe2 aqueous. So balance is there's no oxygen, so there's no need balancing hydrogen. So the only thing we balance here is charges. The charge here is 0, the charge here is +2.
Yes.
So we add we'll be adding electron to the side with the higher charge.
To E to the right hand side.
Okay. So as simple as that, just add 2 electrons here. That's all.
Okay, yes, to the left hand side.
So we add electron that way. That is the balance, that's the oxidation half equation. That's just it. Then we'll come to reduction half equation. Reduction half equation will be 2 silver, that is Ag aqueous, the silver ion, give me 2 Ag, sorry. So if you check here, oxidation number here is +2, oxidation number here is 0. So we are adding electron to the left hand side, that will be 2E minus. So that's just it. So this is your balance reduction half equation, balance oxidation half equation. They didn't ask us to write the overall equation, because if you are to write the overall equation, it will take you back to the initial question, because the charges are 2. If you cancel out the charges and combine it, it will take you back to what you have here. Hence, they didn't ask you to write the overall equation.
I don't know, maybe it's my own network. I'm not hearing it.
It's not network, it's not your network, it's my own network over here. Can you hear me now? Can you hear me now?
Okay, I can hear you, sir.
Okay.
I can hear you now, but
Okay.
to see the video is something else.
But can you see it now? Is it better now? Is it better now? Sorry. So, like I said,
It's not so.
let me see if I can bring it closer. Is it better now? Is it?
Yes, a little bit better.
Okay. So if we are done with this, let's
Yes,
go to
can manage.
Okay, the next one was write or which of the species is oxidized and reduced. If you check here now, this is 0 to +2 undergoing oxidation, +2 to 0 reduction. So species oxidized is Fe, species reduced is Ag plus. So species oxidized is Fe, not Fe2 plus, but just Fe. While the species reduced is Ag plus.
Yeah.
I won't answer that. The next question was state the change in the oxidation number of silver during the reaction. State the change in the oxidation number of silver. The change in oxidation number of silver, silver is Ag. You can see this just plus. So it's changing from +1 to 0. So the change in the oxidation number is from +1 to 0. I think that has answered the question. Is that taken? Can I clean now? Let us look at one question on how it will come in an objective situation. Okay, look at this question. The question was in the reaction above, why is that? In the reaction above, why is that? This is an objective question. So the student could be faced with balancing redox reaction in an objective situation. They say, A, why is that? Let me just give options to guide us for subsequent time. +5, B, C, and D. So what do you think is the answer, please? A, B, C, D. What is the value of Y in this equation?
I cannot.
Okay, if you cannot see, let me
I
just.
cannot really see what
This is
We
M.
are not seeing the board again.
Okay, let me
Really see the board though.
this is MN.
So we are not seeing.
Let me read it out for you. This is MnO4 with a minus
It's like the network.
plus Y plus 5Fe2 plus. Let me just say if it's to be better.
Is breaking.
The network is very bad.
Can you see the bucket now? Is it better now?
Yes.
For me, it went off again. Or it came up and just went off again.
Sorry.
That's even went away again.
It is well. If it goes off this time.
That's went out again.
So, but my network here is stable. I don't know if it's from your end there.
I think it's network issue. It is up now.
Okay. Can you see the board better now? So this is MnO4 minus
Yes.
Y plus 5Fe2 plus
Okay.
give you Mn2 plus 5Fe3 plus 4H2O. And the question is, what is the value of Y?
That's gone off again. -4 minus.
What is the value of Y in the above equation? So A, 5H plus, 4H plus, 10H plus, 8H plus, respectively. So what do you think is the answer? Can you see the board?
No.
No, not clear. No.
Okay, we are left with 4 minutes quickly. Let me just find this up. The value of Y here, if you check here, this Y is talking about the hydrogen ion. So if you check here, 4 times 2 will give me 8. So your Y is simply 8 hydrogen ion. That's the value of Y. So which is option D is the answer. Is that taken?
The network is really bad.
It's the same here. Seeing the screen is a big challenge.
Sorry.
It has come up.
Mine went off again after coming up.
It's your network.
It has gone again.
It's your network because the network
Has gone off again.
It has gone out again.
The network here is stable, so and I'm seeing both of you here. So I don't know how come your own network is off and on, but it's network anyway. It goes all the class ends in next 2 minutes. So obviously I will call it a wrap here. But if you have any other question, you can always let me know. I will attend to it on Telegram. But of course. So let the students know how to balance Redox.
So much appreciate you, sir. God bless. I've really learned a lot. I didn't know how to do this before.
Thank you so much, sir.
Well, thank God.
There are some areas I've been having challenges, but with your class now,
Yes, so
So which other areas?
those areas have been well touched. Yes, there are 2 major points I've learned already from this. No, I said there are 2 major points I've learned. Number one is the reason why we have hydrogen and water in the balancing of the equation. So that riddle has been solved.
Okay, thank God.
Then I think there was another thing I learned in the first topic you treated. Yes, having to do with the oxidation and reduction group, the naming of the compounds.
Okay.
To know which to start with. So
Okay.
I really benefited a lot.
Okay.
Yes,
Sometimes you can
I
have
really
four,
benefited a lot. Thank you so much.
welcome. But sometimes you can have
Yes.
4 elements. I didn't mention that, but just let me just say, for example, now we have NaH CO3. This is 4 elements in a compound. When there are 4 like
Which of them?
1, 2, 3, 4. Can you see the board?
4 elements. Okay, yes. When you have 4, how does it go, please?
Okay, when you have 4,
Yes. I've seen one like that. I think one of the last white. Yes, this one is sodium hydrogen triisocarbonate 4. It's not so.
yes.
I mean, yes.
We name 1, 2, 3, and 4. 1, 2, 3.
Yeah, I cannot see the board now.
Like,
Sodium. Okay, 1, 2,
3.
Okay, sodium is 1, right?
Yes. Hydrogen,
Sodium is 1.
hydrogen 2.
Hydrogen is 2.
Oxygen 3.
Good. Then oxygen 3.
Then the carbon is 4. With the oxidation number of
3.
carbon
Then
attached to
carbon
it.
4. Thank you very much.
The last one, you always calculate the oxidation number
Okay.
of the last one and attach it to the name of the compound.
Yes.
Yeah, so that is it. So maybe another day we'll look at how to write formula of compound from the name.
Okay.
So,
All right. Thank you so much. Hydrogen trials. Yes, I benefited a lot. Thank you so much. Yes. I'm grateful. Thanks for the class.
Just
Your time, effort.